Yeah, thank you. Good morning. Welcome to the Knutsaal, which we don't know why it's called like that. Welcome to talk about performance awareness and then a bit about optimization as well. Once upon a time, pre-COVID, before my two children, before like 8 UK prime ministers or something, I studied computer science. And as part of that, we did a practical lab where we built an operating system. So managing I/O, memory, paging, scheduling, tasking, whatever. And as part of that, there were specific tasks and specific places in the operating system, request, lifecycle, whatever you want to call it, where we measured some things. We didn't know that in advance. I think we were teams of 2 people, maybe 10, 12 teams. And the team that I was on, we won. And that surprised me because, again, we didn't know about that and we didn't do optimization. What we did do when we built the operating system was just think about what could happen, what kind of different states could we be in, where do we want to go in, and what kind of overheads could that be. If there are 2 things, 3 things, is there an order in which they should be checked or done, or things like that. So, small disclaimer, what this talk is not about. It's not a talk about AI, sorry. It's also not your front-end performance, SEO, lighthouse, whatever kind of talk, which you might expect when you read performance, at least not specifically. And this is also not a talk where I tell you, these are the 10 things that you should do always in any kind of project. That's not how this works. So what is this going to be? It's a set of guiding practice or best practices, guiding principles that I just discovered, adopted from other people, and they are common sense usually. So you don't learn a lot of new things, I would say, but yeah, relearning things that we should know and should follow is also good. So this is about adopting a performance mindset. It's not applying performance tactics. It's thinking about how to write things, systems, software, build hardware that perform well. There are code examples, but they're just for illustration. So if you just copy that and the use case allows for that, that's great. What you really should try and do is understand the concept, what we're doing there, and then translate that into your context, into your project, your tech stack, and whatever. Depending on the context, some things that I will show here or talk about are not as important or maybe even not true at all, they don't apply. So for example, do you have garbage collection? Then maybe you don't have to care about memory as much as in other contexts. Is there some form of compiling, transpiling, even optimizing the code? Maybe you don't have to talk about, care about things that, for example, PHP is literally parsed and other languages. And also, there's always competing interests in software development. So let's say we want to improve performance, but there are other aspects that have something to do or maybe even play against performance. So code should perform, but it should also be usable. The software should be usable, it should perform well, but it should also be usable, and the code should be readable. You should be able to easily debug the code. You should be able to maintain your software projects easily. And then also there's the balance between processing resources or capacity and storage, memory. If something should really be quick, you could try and store stuff in memory, but if you don't have memory, it cannot be quick. If you want to optimize, you have to pick both, or pick one over the other, and there needs to be a balance. So in the end, it's not always about performance, depending on your context. If you build an operating system, maybe it is. But what is performance? The definition, or one of the definitions of performance, is how well a task is being executed. And well, what does that mean? Well, so if we're talking about technology, IT, it's for example the response time. How long does it take to execute that task? If we're talking about a system, hardware, what about the processing speed? How long does it actually take to process something, and not maybe the full request lifecycle of reading something, processing, post-processing, and sharing, and I don't know, pushing something somewhere. What about the resources? We said before, like processing resources, the CPU, GPU, what about the memory? If we talk about your system, how available is your system? When we talk about music, how do you like the performance of that artist? That's also personal preference. It's based on the expectation. What are your expectations, and what do you base this being well performed on? And of course, there are many more. The list of guiding principles, as I said, are common knowledge, most of them. We start with don't do work too early. When we realized there is work to do, we shouldn't do work over and over again if nothing changes. Also, we don't need to do unnecessarily complex work. Sometimes a task involves complex things or maybe multiple things, but if they're not necessary, maybe we shouldn't do that. Also, don't optimize prematurely. I guess you heard that. Sometimes you think about, you're building something, and then while you're building, or maybe even before, you're already thinking about optimization, and I don't know, that doesn't really work unless you build it and tested that in some context. However, you should measure performance if you care about performance. That is, you build something, you test that, you use that, and then you measure. And then you know where stuff is not performing well based on your criteria. Also, we need to clean up ourselves. That's true in life and software development. And also, of course, if there are multiple tools, multiple approaches, multiple libraries, or I don't know, algorithms, you should know about some, and then you need to understand like how do they differ, which of these things is best or the right tool for the job that you're doing. So let's start with the first one. Failing early is something that's easy, and sometimes not done for no apparent reason. So one way to fail easy is we check the context. That means, should we actually do something? Consider this, again, just example code. Okay, that's a bit too small on my screen. So let's say there's a function foo. We call the function, and then there is a condition check. We don't know what this is here, but there's some condition that needs to evaluate true. If not, we don't need to do anything. We don't need to talk to some remote API. We don't need to write to the database or something. We just check this condition, which of course may involve all these things, speaking to other resources, but we don't perform our actual task. That could be one example in the WordPress context. So you do something to a post, but you're interested in published versus non-published posts. It could also be that you have multiple checks or multiple conditions, and then you check, is it published post or not? Is it a special post or not? And this is when it can start that you think about these things. This is not really about optimization, this is really just about awareness. So we have two checks. You should know about the data that's in your project. Do we have more published versus non-published posts? Do we have more special versus non-special posts? Maybe you want to switch these conditions. It's a simple equal or disequal, unequal sign, but it is an operation. And if you know that 90% of your posts, 95% are published, maybe you should check that first, maybe not. What I guess everyone understands is if there is an expensive check, we maybe don't start with that, but the simple ones. Maybe you start with the expensive check if you know that will catch like 95%. That's up to you again. You need to know the project, you need to understand the code base, the context, the data, maybe the interaction. What about data? Let's say we have a function that processes data based on some ID, some object, or a URL or something. So let's say we do something, then we get the data based on the post ID that we have, then we do something again, we process the data, and we do something again. So this could, for example, be a batch process, a CLI command. Where do we get the data? It's here. We already maybe kicked off something. We've written to the database, we opened screen connections, or I don't know. Why? If we don't loop over data because we don't have data, why should we do that? Maybe we need to do some things. For example, if it's a CLI command, we need to write like checking for data. There's no data, then we're done. So we could check for the data and then be done, or as I said, do some minimal messaging or whatever the context really requires here, so that the person using our software knows something is happening. Caching. I expect caching is one of the things that people think of in the first three aspects of optimization and performance. We should cache expensive operations. So we don't want to spend time or resources on something that we know doesn't change, but we could do ask for 5 times. And if you want to bake a cake and you don't have the recipe, you don't call your mom and you do the baking while she's on the phone, and then you realize, oh, I wanted to bake 3 cakes. Now you have to call again. What you would do is you ask for the recipe once and you write it down so you can go back to that again. So caching expensive operations could be we cache something in the local context. That's, for example, a static context, or it's in a class context, it's an instance property or something. It could even be a hyper-local cache, so it's just in that one function. We want to store something here because in that one function, we would need to check or use a thing 3 times. We don't need to ask for that thing 3 times. We can just store it in the local variable, and that's great. Caching could happen on the session, in the session context. It could happen in the request. For example, in WordPress, we have global variables that share context or state between the request. There could even be an actual long-lived cache, object caching, for example. And then, of course, we come to exploration and invalidation, one of the easy things in software development. We also should cache repetitive operations, regardless of their complexity, again, if we know the data is static anyway, or we want the data to not change. For example, if we have a long-running process, we ask for a thing, and then some time passes, and if we ask for the thing again, maybe it changed. But maybe we want to refer to the version that we had before. Maybe we have some conditions based on that. So we shouldn't check for something, branch in that one direction, do something, check again, oh, we have to branch here. So it's maybe not the right thing for the process. Repetitive means just, let's keep this handy. We need to know, we need this again to know about having 3 references to the same thing, so we just store this. This could look like that. So we just call a function, store the result in a variable, and then we're done. We could also nested lookups, which are not that expensive, but again, if we nest 5 things and we call that lookup 5 times, it's 25 lookups. For what reason? Memorization is nothing but a special kind of caching. We want to cache the output, results, behavior of a specific function given a specific set of arguments. These are examples in the WordPress or React context. Another thing is we want to avoid intermediaries. Let's look at that. So this is a function, or this could be part of a function, where we get some data, and then we want to filter the data based on something. We want to map the data to another data structure. Maybe even we want to apply a filter in the WordPress context again. So what do you realize if you look at that? Is there anything that catches your eye? How about that? We do the same thing, but we mutate the variable that we have. We don't need data after filtered data anymore. We don't need filtered data after normalized data. And again, do we have garbage collection? Is there some kind of memory resource management? Yes or no? Is this done in the global scope? Is this done in a function that ends after this? That all matters. But is there a reason not to mutate the local variable? If you're thinking debugging, you could still debug all the states of that piece of data. So versus just nesting the function calls, we mutate the one variable that we have, and yeah, then we're done. We don't need to create intermediary data structures. For example, if we want to process data, and we have an array here, we could do it like that. So in lines 2 to 5, we create a new array. Take what we have, add to it, and then in the next iteration we create a new array. How about that? Same is true for objects. We create a new object, destructure everything that we have, but we could also just add to the object, or maybe override depending on what we have. In the WordPress context, maybe somewhere else as well, there are, I don't know how to call them, there are functions that expect an object identifier or an object. So it's illustrated here like post or post ID. And let's say the context is we do have a post ID. So what we could do is we call the first action pass the post ID, the second action the third action. But what we also could do is fetch the object and pass the object around. That might not make a difference depending on what you're using. For WordPress, it does make a difference. For example, the get post query fetches data from the database because the literal translation of get post means get the post data from the database. There is no caching, and that's by design. So all these functions that take an object or the ID will ask the database for the object, which didn't change in the 1 millisecond from the last call. There's also control over how functions are being executed. One way to do that is throttling the function call or execution. This just means we will do what you want us to do, but at the pace that we decide. For example, there's an event listener that reacts to the mouse being dragged over the window document or something. Depending on your CPU and browser and whatnot, that will happen way faster or more often than you would need. We could also throttle this drag over callback, the drag over callback here, and decide, okay, this will be executed irrelevant of the times and frequency you ask me, just one time within this time frame of, what is it, 200 milliseconds. Another way to slow down requests or function execution is debouncing. That just means we do this again, but after some cooldown. So it doesn't matter how often you want to call that and what was the first or the previous time we did that. We do it once, wait for a specific time, and if you requested this action or the function to be executed again, we do it again. In this example here, we have a change event listener, and you type something in, and then if you're not quickly enough, you send requests for every single keystroke. That's not what we want. We could also wait for 300 milliseconds after the last keystroke, and then we just ask the API. If you're typing slowly, that still means multiple requests, which you have to abort, coming later to that, but that's much better than like firing for a sentence of 20 characters, 20 API requests. You don't need that. You will not use the data you get back. This is an illustration, if anyone does not know the concept or the naming of the debounce and throttle. At the top you will see just a random execution of some user event. And then if we debounce that, we do it once, and then we do it again after this cooldown time. So you should see that the time before this green line and the last one here is the same. And at the bottom we see the throttle. So yes, we do it on the first request, but not on the second, not the third. We do it after this threshold that we decided to use. Cleaning up. I'm talking about memory leaks here, mainly. One thing that you should do, especially in a dynamic interactive context, is remove event listeners if you don't need the data anymore. You don't need this request to happen or so. So we need to clean up leftover things that might cause side effects or break visually or actually from the function perspective. One way to do that is, for example, we are in a React context. We have a use effect hook. We attach an event listener, And then in line 4 through 6, there is this clean up callback. So when the context of this component changes, we call cleanup. And if the component re-renders and something else changes, so we may add the event listener again. But the one that we added before has been removed before we add the second one. So that's the important bit here. There's also for event listeners self-removal if we're talking about one-time events. That's kind of new. I think like has been introduced like 3 or 4 years ago in the stable browser version. So this basically means react a single time on that action given the target and then remove yourself. We want to remove time-based functions. So we had before here, no, we didn't see that. So set interval, for example. If we want to repeat something based on a specific interval, we should maybe stop that from happening if the contexts that required the data or wanted this thing to happen is no longer there. So if there's a component that needs something to happen, maybe this something does no longer happen or doesn't need to happen if the component isn't there anymore. Again, there might be use cases where that still is relevant, but most of the time it's not. So again, it's a use effect. We have this cleanup hook. We store the interval ID or time ID and then we clear it. Same thing for set timeout. If you use higher order components, in Gutenberg there is actually a set timeout higher order component, so it's called with save timeout. There is none for set interval, I don't really know why. But I guess most of modern projects don't use class components and higher order components. Again, maybe. So yeah, you could use that. So here at the bottom or at the top you see we use that higher order component wrapper. At the bottom we wrap our component inside. And then we have access to an instance method that's called set timeout. And this basically internally does component will unmount, so we just clear. We should abort pending requests. We ask the API for some data, and then the thing processing the data or displaying the data is gone away. We don't need the data anymore. So let's say we use the API fetch library. We could use the abort controller. It's a stable web API, browser API. We pass the signal to this request, and at line 17 through 19 again, this cleanup function aborts the abort controller, which basically means this signals to everyone listening to the signal, you don't need to do anything. What I find interesting is that this is actually an error. So we see that in line 9 and the following. So this catch callback, it's an error, but we can understand what is the error. Is this because this request has been aborted, or is there something else going on? And maybe if it's aborted, we don't need to do anything. Maybe we want to update something, but we definitely don't try and update data, delete previous data or something, because yeah, most likely this context is no longer there, like the component has gone away. We should also cancel scheduled callbacks. So we saw before this, what is it here, a debounced callback. If I'm requesting something to happen, and then again and again, it happened the first time, and then maybe the component goes away, this will happen the second time because I asked for it just after this cooldown. So if we use low dash debounce, there's also a, what is it called, a cancel callback, or cancel method on this object, on this function. So again, we have this debounce callback, and then if the component goes away, we cancel any potentially scheduled requests or function calls. That's about performance mindsets, being aware of what you do. But let's think about some high-level things, simple things, how to measure performance. In the WordPress context, I think one of the two main things that everyone should know about, if not use, is the Query Monitor plugin and all the extensions, also for the debug bar plugin. Inside there are things like database queries. You could just look at the queries, you can filter them, sort them. They are already sorted by caller or by components. You explicitly see duplicate queries queries that you maybe want to look into. Another thing, of course, when we talk about PHP in general, is profiling your process, profiling your application. One way to do that is using Xdebug. There's the built-in profiling functionality. I'm just mentioning some things so that you know in which direction you can think or just explore, depending on your computing hosting context. It might be that, for example, AWS has the X-ray service, which stores a lot of data depending on how you configure that, and you can retroactively replay the request. You can see what happens with what kinds of data, what external database API requests have been done, and all these sorts of things with timing. You could have flame graphs or icicle graphs, similar to profiling in Xdebug. Of course, as a developer, there are an array of browser dev tools. For example, you can look at the network, like what happens in terms of resources, timed and synchronous, deferred, asynchronous. There's the performance tab. There are extensions for things like React itself, Redux, both of them which you can use in the Gutenberg context. I know that both Chrome and I think Firefox have added something like performance insights, which is more insights into the performance space. I don't know if the plan for either browser is to replace the performance tab with that. There's definitely some experiments going on. Thinking about the database, it's possible using MySQL or MariaDB and other database systems to turn on profiling. So for example, if you locally or on some online environment where you have directed or implicit access to execute some SQL commands, you could turn on profiling, execute whatever you want, and then look at the profiles, or you can look at a specific profile. You see timing of things that happen. Another aspect is, if you want to understand queries, of course, you can explain or you can ask SQL to explain queries to you based on the indexes that you have and other things, which gets to know your tools or your environments. This is unique for everyone. So for your tech stack, for your language, for your target, like are you front-end focused? Is your application front-end focused? This is unique for every environment. Is this in the cloud? Is this local? Is this shared? Is this a, I don't know, like complex, multinational, whatever kind of system? Do we have extensions turned on or not in PHP, in, I don't know. And of course, this is unique for every use case. So in general, you should just be interested in things on a high level. And of course, if you want to optimize things or not have to optimize things, maybe you don't need to invent something that's there already. And if there are multiple versions of libraries or so, pick the one that's the most used, the most maintained or so. Things like the functions in Lodash, yes, you can write your own debounds, but maybe the Lodash one is better. So yeah, and also there's no real reason in terms of like bundle size or so. You don't need to pull in Lodash if you want one Lodash function. So that's not the case again. For example, in the WordPress context, don't use meta tables, post meta, term meta, or something if you query on the value basis. And if you really have to, maybe you should have an index, partial, so. And of course, there's a lot more, but I ran out of time. Are there any questions?